This is all, not on the screen. This is all review for the most part. We are very, very rapidly getting out of the point where Algebra 2 trig is Algebra 1 on steroids. But right now it's what it's been. Even quadratics was a review mostly of Algebra 1 with just a few new things and more difficult things. Matrices was new, but other than that, everything's been an Algebra 1 review, and so is today's lesson, but we're getting out of that pretty quick. We're going to start doing really Algebra 2 trig as opposed to doing Algebra 1 on steroids, which means you might have to up your game a little bit. Whatever your game is, it might have to get upped, because we're just moving on to new material as opposed to reviewed material. There are basically four main properties of exponents. Your book actually lists a lot more, but all the properties of exponents are just some combination of these four. The basic one, the most rudimentary and common one, is x to the a times x to the b equals x to the a plus b. Which basically means if I have the same base and different powers, if I multiply those, I add up the powers. So 3 to the second times 3 to the fifth equals 3 to the seventh. And I could actually calculate that. 3 to the seventh is some big number, I don't know what it is. But I could calculate that. If I had like x to the third times x to the fifth, I add up the powers and that becomes x to the eighth. I think it's very, very helpful to understand why properties are the way that they are. And one thing that I say a lot that you're going to grow very sick of is when in doubt, expand it out. So for example, x to the third really just means 3x's. X times x times x. X to the fifth really means I have 1, 2, 3, 4, 5 x's. So if I'm doing x to the third times x to the fifth, there's really 8 x's altogether, and that's why it's x to the eighth. That's why the powers add. You're really just smushing these x's together. Division has a very similar property. If I have like x to the seventh over x to the fourth, I do 7 minus 4, and that becomes x to the third. I just subtract. And again, if you want to think about why that is, x to the seventh would be 1, 2, 3, 4, 5, 6, 7 x's on top. X to the fourth is 1, 2, 3, 4 x's on the bottom. And x divided by x is 1, so these can cancel, and x divided by x is 1, and these can cancel. And literally, the 4 x's on the bottom are taking away 4 x's on top, taking away a subtraction. We're left with 3 x's on top. So that's x to the third. The division becomes subtraction. And the special case you kind of want to worry about, something that's special, happens half the time, is if the power on top is less than the power on the bottom. So this would become 3 minus 5, which is negative 2. We can never have negative powers in these problems. Whenever we simplify, we're not going to have negative powers. If I think about what's really happening here, there's 3 x's on top, there's 5 x's on the bottom. Take away, take away, take away. I'm left with 2 x's on the bottom. It really becomes 1 over x squared. And that's what this property here is saying. X to the negative 2 is really 1 over x squared. A negative power does a reciprocal. It flips the thing over. So like if I had x to the negative 8, it becomes 1 over x to the 8th. And if I had 3 over a to the negative 4, well, this a to the negative 4 is on the bottom of the fraction. The negative power flips it and moves it to the top. So it becomes 3a to the 4th. Kelsey, were you about to ask a question?
No.
Yeah. You've taken me out twice pretty well.
I know.
Like
I
1,
noticed,
2.
but
It's pretty impressive. The negative power flips where you are in a fraction. So to do a few more examples, because this usually needs some examples. I think I'll just jump over here. If I had x to the negative 3 over x to the 5. Well, what a negative power does is change the position of the fraction. So right now this is on top. The negative 3x's are going to move to the bottom and become positive. So on top I just have a 1. There's always something up here, so there'll be a 1 up here. And on the bottom there's an x to the 5th and an x to the 3rd. So it's really x to the 8th. 1 over x to the 8th. And if I had like something like this, b to the negative 5 on the bottom is going to move to the top. It's all over 1, which I don't bother writing. There's just nothing left on the bottom. So when you're simplifying these, you can never have negative powers. Okay? Always flip the negative power to the other side of the fraction. The last thing that people find tricky, this is really when things start to get complicated actually, is when you have powers of powers. X to the a to the b becomes x to the a times b. So if I had like x to the 5th to the 3rd, it becomes x to the 15th. I multiply those powers. To do a simple example, x squared to the 3rd. Well, x squared means x times x. If I'm doing x times x to the 3rd, that means I'm doing that 3 times. There's really 1, 2, 3, 4, 5, 6 x's. X to the 6th. So you multiply those powers. The power of a power becomes multiply. And there's a whole bunch more rules that the book is going to show you that I'll have to put on a slide in a little bit for just a brief moment. But they all are just some combination of these 4. Every property of exponent that we're going to see right now is the combination of these 4. There's really one more basic one that we'll see next chapter, but these are the main 4 that we deal with. So, we eventually start having some fun simplifying. When I'm simplifying, I want to get rid of the parentheses, combine all the variables, and have no negative powers. That's my goal. Get rid of the parentheses, combine the variables, have no negative powers. I'm always doing the order of operations, especially when simplifying. So I want to simplify everything inside this parenthesis here first. I'm doing this problem. Everything inside that parenthesis. So 2 divided by 6 just becomes 1 over 3. I'm not going to put the 1 on top. We'll see if I need it or not. But 2 over 6 is 1 over 3. A to the 3rd over a to the 5th. Well, I do 3 minus 5, which is negative 2. Which really means that there's 2 a's on the bottom. Over a squared on the bottom. So just basically 3 of these a's cancel 5 of these a's. I have a squared on the bottom. And with that b to the negative 2, these negative 2 b's come down here and become positive. So it's like I have b to the 7th and b to the 2nd. So I really have b to the 9th. So on top I just have a 1. And that's how that would simplify. I have the a's deal with each other, have the b's deal with each other, have the coefficients deal with each other, and then put it all together. Question about that one? There was 2 b's on the top that went down to the bottom. So basically you asked how did I get that 9?
Okay, so it's like moving one number from
right.
the equal sign to the other. So
yeah, it is kind of like that. You think of it that way. Yeah. I mean, if you want to think about the actual rule itself, we talked about how we're really doing this rule here. So I'm really doing b to the negative 2 minus 7, which is b to the negative 9, which is 1 over b to the 9, which is why it's on the bottom. Is b to the 9th. That's kind of the way to grunt it out if you're really stuck. That's kind of the last resort for me. But I just think if they're negative on top, they're positive on the bottom. Will you please try this one here? If you finish it, you can try the next one, but you can take a pause in between if you want. Pause. Okay, if I square everything in this first parenthesis, negative 4 squared is positive 16. It's not negative 4 times 2, it's negative 4 squared. If you want to think of it like there's a power on this, you could. So I'm really doing negative 4 to the first times 2, which becomes negative 4 squared, but it's positive 16. I'm doing negative 4 times negative 4. X to the 3rd squared is x to the 6th, and y to the 5th squared is y to the 10th. And this 2x to the fifth, 2xy to the fifth just stays 2xy to the fifth. Now when I multiply these, I'm just going to put together the things that are the same. So 16 times 2 is 32. X to the sixth times x to the first is x to the seventh. Y to the 10th times y to the fifth is y to the 15th. I'm going to check that to make sure that's right. Okay.
For the 2xy to the fifth, why does it put 5 equal 2?
Because here, just the y has a fifth power on it.
Oh,
The x doesn't have a power and the 2 doesn't have a power. Whereas here on the outside of the parentheses, it's like everything is being squared.
okay.
How could I check that to make sure it's right? You know? I can pick numbers for x and y. I can plug a 2 in for an x and a 3 in for the y and calculate whatever this is. Do that in my calculator literally, with x being 2 and y being 3. Then do the same thing down here with x being 2 and y being 3. And they're going to be enormous numbers. They'll be in scientific notation. But if they're the same, I've done it correctly. You can actually check all of your simplifying that way if you want to. Just plug numbers in for those x's and y's that aren't negative 1, 0, or 1. Don't plug those in when you're checking simplifying. I'll give you a little bit more time on that one on the right. On that one too. Okay, here's an important thing to understand. Negative 5 to the third is negative 125. Because negative 5 to the third is negative 5 times negative 5 times negative 5, and that's positive 25, so that makes it negative 125. If you have a negative number to an even power, it will always come out positive. If you have a negative number to an odd power, it'll always come out negative. So when it's an even power, like if I did negative 4 to the sixth, well, it's going to go negative, positive, negative, positive, negative, positive. The even ones always make them positive. All that to say, negative 5 to the third is negative 125. A to the negative 3 to the third is a to the negative 9th. B to the second to the third is b to the sixth. I can't move things around in this problem without getting rid of those parentheses first. So you might have tried to move this a to the negative 3 down. You can't do that because it's buried in this parenthesis. You have to do the order of operations. On the bottom, I'm going to get 125 a squared b to the negative fourth. 25, not 125, 25. I get so excited I'm wrong. You're like, I got you now. Negative 125 divided by 25 is a negative 5 on top. The bigger number will stay in the spot. Since this number was larger than this number, it ended up on top. A to the negative 9 over a to this positive 2. Well, the negative 9 comes down here and becomes a positive. So a to the second and a to the 9th put together become a to the 11th. And these negative 4b's come up here, and that becomes b to the 10th. So I have negative 5 b to the 10th over a to the 11th. And that I could also check by plugging in 2 for a and 3 for b, and doing it in the first problem and then the result and see what I end up with. Let's see.
Did we do something like this question?
Yes, this is review. This is review. Last thing we'll do, simplifying. These are all the properties of exponents. I don't bother writing them all out because they're all the same. It's just the first 4 we talked about. Ooh, this one I probably should have mentioned. X to the 0 is 1. I'll come back to that one later. Remember, you can multiply anything, but you can only add and subtract like terms. So if I'm going to multiply these, I do 5x squared times 3x squared is 15x to the fourth. 5x squared times negative x is negative 5x to the third. Negative 2x third times x is negative 2x to the fourth. Negative 2x to the third times 4 is negative 8x to the third. Then I combine my like terms. 15x to the fourth minus 2x to the fourth is 13x to the fourth. Negative 5x to the third minus 8x to the third is negative 13x to the third. I can't go any further than that because those aren't like terms. I can't add or subtract on like terms. Only multiply and divide. For this last one, I'm going to FOIL 3 times, basically. There's lots of multiplying that takes place. I recommend you stack them on top of each other by columns. I'll show what I mean. A squared times a squared is a to the 4th. A squared times a is a to the 3rd. A squared times negative 2 is negative 2a squared. At the bottom, when I do 3a times a squared, I get 3a to the 3rd. And I put these on top of each other by columns where the powers match up. 3a times a is 3a squared. 3a times negative 2 is negative 6a. And I can add these up. A to the 4th plus 4a to the 3rd plus a squared minus 6a. Yay! That should cover your homework, which is long but shouldn't be super hard.